All right, so before we get into adding and subtracting rational expressions when the denominators are not the same, meaning they're unlike, let's let's first look at how to find the LCD. And just in teaching, I know have noticed that finding the LCD has been very difficult for students. So I'm going to show you in a different manner of how to find the LCD, and we're going to use the Venn diagram. And this Venn diagram shows relationships, and it doesn't show any relationship. So that's why you see here where it says same versus different. So I'm going to show you how to find the LCD, and we can also use the Venn diagram to find the GCF, greatest common factor. Okay, so for this example, since it's asking us to find the LCD, our focus will be only on the expressions that we see in the denominator. Now, the numerator, we'll focus on that later as we do more examples with adding and subtracting rational expressions with unlike denominators. But for right now, let's focus on the denominator. So let's look at the first fraction. We have 20a squared b to the third power. That is a 3. And then we also have 15ab to the fourth. And we want to find the LCD for those expressions. So what I want us to do is list the prime factors for 20 and list the for 20a squared b cubed and list the prime factors for 15ab to the fourth. And we've been working with prime factors. We know how to use the prime factorization tree. But let's look at 20a squared b cubed. We want to list the prime factors. For 20, we know that when we branch off 20, we have 4 times 5. So the prime factors are 2 times 2. We have a 5. And then we have a squared b cubed. We're going to write out the number of a's we see and the number of b's we see. We have 2 a's and 3 b's. For 15ab to the fourth, the prime factors are 3 and 5 for 15. We have an A and we have 4 B's. So the easiest way to start off with is finding out what is the same. So before we do that, let's go ahead and label the circles. Our first circle will represent that as 20 a squared b cubed. And then our second circle will represent that as 15a b to the fourth. All right, so what is the same? What does these expressions have in common that you see? We see it has a 5, a set of A's, and 3 sets of B's. Okay, so if I were to ask you what is the GCF of these expressions, the GCF would be 5AB cubed. That would be the GCF, but I'm not asking you to find the GCF. Well, but if I were using the Venn diagram, we would look at what is the same, where the two circles overlap. But let's finish this out. What is different? So using the Venn diagram, my first circle needs to represent 20a squared b cubed. So you're saying, okay, what is missing? And we're going to include that in the different portion of this circle. Well, let's go back. What did to our prime factors? What did we not cross out? we didn't cross out a 2 and a 2 and an a. So that would be what's different for the 20a squared b cubed. Now, when we multiply all of these factors, this is what it's going to equal to. Let's look at our 15ab to the fourth. We see what we have. That's in the same where it for both expressions, but what's different? Well, let's look at our prime factors. What did we not cross out? We didn't cross out a 3, and then we didn't cross out a b. All right, so look at all the factors that we have. To find the LCD, multiply all parts of the circle. All parts. What's the same and what's different. So for this question, to find the LCD, we're going to multiply 2. We're going to put it in numerical order, in alphabetical order. We have a 3, we have a 5, we have 2 A's, and we have 4 B's. Multiply all parts, all parts. So our LCD is 2 times 2 times 2 times 2 is 4, times 3 is 12, times 5 is 60. So we have 60 a squared b to the fourth. That will be our least common denominator for this example. Example 2. Now, because we're dealing with rational expressions, that our denominators could be uh, a binomial, a trinomial, a polynomial of 4 terms. So, um, so sometime we may have binomials as our LCD. So question 2, we have 5 over a plus 8 times a minus 5, and then we have the second fraction, a minus 2 over 8, a plus 8 times a minus 7. We want to find the LCD. So our focus, our main goal is just to look at the denominators. So my question to you, what is the same? Okay, so I'm going to go ahead and write out what should be in each circle. What's the same? A plus 8. And then let's look at the first circle. What will be different? A minus 5. And then the second circle. What will be different? A minus 7. Then to find the LCD, multiply all parts of the Venn diagram. So our LCD is going to be a minus 5 times a plus 8 times a minus 7. 3 binomials, and that's okay. As we go into the next set of examples, how to convert, finding the LCD, this Venn diagram is going to be very beneficial. Our last example, number 3, we have here m minus 4 over m squared minus 2m minus 48. That's the first fraction. The second fraction, we have 5m over m squared minus 6m minus 16. So we want to find the LCD for those denominators. Before we do that, let's factor the denominators. M squared minus 2m minus 48. Minus 48. So we're going to have opposite signs. M and M for the first term. We're looking for factors of 48, that when we add those factors, it would give us negative 6. Excuse me, negative 2. I'm saying the answer. So 6 and 8. 6 is going to be positive, 8 is going to be negative, and then the second fraction, our denominator, m squared minus 6m minus 16. Minus 16, minus sign, we have opposite signs. M and M for the first term. Factors of 16 that would give us negative 6, that will be 8 and 2. 2 is positive, 8 is negative. So now that our denominators are factored, let's go ahead and fill in the Venn diagram so we can find the LCD. What's the same? M minus 8. Then for the first circle, what would be different? M plus 6. And then for the second circle, what would be different? M plus 2. So to find the LCD, multiply all parts in the Venn diagram. We'll just bring it together. So m plus 6 times m minus 8 times m plus 2. And that is our LCD.